Okay, thank you, sir. Thank you. Uh, First of all, I would like to thank the management of NBKR Institute of Science and Technology. And one more thing is, still I am the student of NBKR IST. Not I was, I am the student of NBKR IST. The reason behind it is the institution where now creates a confidence among all the students to cope up to the any environment in the industry. So initially, it was a great platform for me. Hello, can you hear me? Yeah. Initially, it was a great platform for me when I was the student of the institution. When I was pursuing PG, great opportunity has been provided by the institute, to give trainings and personality developments to the undergraduate students, those who have stepped into the organization. And I have started my teaching career from there. And finally, institution has given an opportunity to train the technocrats for 3 years. And fortunately, I have shifted from computer science and engineering background to the mechanical background. Being business coordinator, I used to take care of all the activities and acts as the bridge between the organization and as well as to the customer. Especially our customers are purely DRDO, Defense Research Development Organization scientists, and as well as Indian Space Research Organization scientists. And moreover, our organization is purely in the R&D and slowly entering into the production. Now, massive production, we are going to, move further from the R&D. I would like to quote one thing to all the mechanical engineers and young technocrats, those who are grasping. Opportunities are more. See, nowadays people are leaving to software, stating that the market is fine. It's a temporary. And I would like to tell you, even I have tasted cup of software tea also, where I have seen actually the working background there will be half an hour, and more than 1,000 people will be working on the same project, and you will be one among the crowd. But whereas here your efforts will be recognized. And I would like to explain, one by one. After coming here, even along with me, there were few people who moved from the same institution, and their lives and their career path, how it is lying. Also, I would like to explain. For that, Vikram sir has requested me to explore the opportunities, especially for the mechanical engineers in the core background and upcoming technology, that is space technology. Especially the material is composite material is replacing the metal, steel. Now it is dominating the entire world because of a lot of characteristics that lies in the material. First of all, I hope you would be knowing what exactly composite is. And once again, I would like to tell you very clearly. In general, composite is nothing but a combination of one or two material together will form a composite. It's a composition. So here coming to the fiber reinforced polymer, what we do is we are going to consider two or more materials. Let it be a fiber material. These fibers are are reinforced with the matrix. It's a chemical composition will be added into that. And in this formation, we are going to form a structure in whatever we may want. That structure will be light in weight. Because of light in weight, composite material is predominantly dominating the aerospace and defense industry. And here I have brought one slide for you. That is the history of the Boeing from 747 to the 787. How the metal and other steel material are totally replaced with the composites. And what are all the opportunities that you people will be having in this industry will be explained line by line. See, in general, I hope you have understood what is composite. Composite is nothing but a combination of two or more material, right? And these materials are reinforced with matrix material, that is nothing but a chemical composition. In general, I am telling it is going to form a composition, a composite material. Coming to the specific one, we always deal with fibers here. We have glass fiber, carbon fiber, armored materials are there. These fibers, it's like a dry fiber. Even fabric, nothing but a fabric. We are wearing shirt. Shirt is nothing but a fabric. Am I right or not? In a similar way, we have a fabrics here. These fabrics, what we do is we cut into layers. Layer by layer will be, totally reinforced. Reinforced in the sense will be bonded together with a chemical composition that is called matrix material, what we call the resin system. Resin system. Understand the point. Here the resin system, what we use, mainly three material, varieties are there. One is polyester resin, another one is vinyl ester, and epoxy. Epoxy is having very good adhesion. That means bonding characteristic is very good. Mostly we use epoxy system here, and majority of the fabric material we use here, one is glass fabric and carbon fabric. Now slowly this glass fabric is totally dominating by the carbon fabric. The reason behind it is carbon fabric light in weight. So there is a GSM calculation, gram per square meter calculation. If you go and search in the internet, you will find out for each and every material there will be a GSM value. That GSM value it purely depends upon the density. What do you mean by density? Density is nothing but your mass by volume. So anything that you take, for example, if I ask you what is the density of the population, right now in the mechanical conference hall, then definitely you will be telling that how many people are there and how many people can be accommodated. You understand? See, for every material there will be a density. So that density is nothing but mass, weight by volume. Volume is nothing but here a space occupation. At the same time, weight. Weight itself is nothing but mass value. How much weight that is going to come. For example, I would like to tell you, we are working for ISRO. We have been supplying various components. These components, initially they were used by using different material, metals also they used. But slowly it has been replaced with composite material, carbon composition materials. The reason behind it is light in weight. If you weigh the tube, 2-meter tube, it will be in grams. The same 2-meter, if you take aluminum tube, it will be in kgs. You understand? See, the point is when the rocket is going up, the weight also should be very less. That is one point. Coming to the second point, you also know very well, rocket is carrying propulsion, oxidation, propulsion, both in the form of solid and liquid. That is rocket fuel. So when you burn that 5-kilometer radius, if you see, no one, if you are there in the 5-kilometer radius, you will die. So if that is the case, rocket is carrying components, satellites it is carrying to the high altitudes. Then you understand what type of material you have to use. You tell me the thermal conductivity, the temperatures will be at higher degree. There should be a material which should withstand for that material. What is that material here? Composite material. Your carbon material, which is reinforced with a resin system, will withstand for higher temperatures. That means your composite material is having high resistivity to the thermal conduction. So whenever there is a thermal conductivity, high resistance, so at 1000 degrees Celsius temperature, it will not melt. I hope you understood the second characteristics. First is light in weight. Second is the high resistivity, thermal resistivity. Coming to the third one, there is a Kevlar fabric which we are using. If you know, elongate that Kevlar, your finger will cut. The usage of Kevlar, I will tell you in the war, right? These body-proof armors are there, and body-proof jackets that is made up of with your composite material. Their armored your Kevlars will be used, Kevlar fabric. You know, because the strength, if you hit to that, your hand will break. That is the third characteristic. Coming to the fourth one, in case if you keep your metal there outside, it will subject to rusting. That is called as corrosion. That means to the nature, your metal is going to react. But whereas if you throw that carbon material outside, if you see the structure outside for 1 year, it will not rust. That means coming to the chemical reaction, it is the reactive nature of the composite material is very less. So the reactiveness of the composite material is, very less. It will not react. It will not subject to rusting. There won't be immediate damage. There won't, that means lifelong. No, no. For example, if metal life is 15, whereas composition material or composite material life would be for 20 to 30 years or 40 years. So these are the characteristics. And coming to opportunities, I would like to tell you very clearly. If you are going to enter into the composite industry, what benefit being a mechanical engineer you will be having? Boss, initially, I would like to tell you to all the people, coming to the earning point, initially you will be getting less amount. So this seminar is only for that. You are not supposed to compare with the software industry. Software market is fine. In case if recession comes, it will go out. But this is an evergreen field, which is upcoming. The same composite material is used for the chassis in the heavy vehicles. Do you know that in Sri City you have a composite material industry, BFG. Industry name is BFG. Do you know that all the metro bodies are made up of carbon? You may not be knowing. In and around, you have very good industries related to the composite. In Kadapa, especially in Kadapa district, one more industry is there. So they used to repair the all the metro train body. That you may not be knowing. But when you step into that, you will get less amount. The less salary you will get. Once if you prove, once if you are going to prove yourselves coming here, if you are able to learn the technology, definitely you will be master after 5 to 10 years, and you will be hot cake in the industry. You will be one among the 10 members. I would like to tell you, there is a person, his name is Mr. Mohan, who is doing NDT, non-destructive testing. That means after fabricating the material, once the structure is formed, so it is nothing but a layer by layer composition. You have to check whether these layers are properly bonded. That means in between any layer gap is there or not. He has to check. So for checking that, you have a non-destructive testing method. The terminology here is debond, delamination, porosity. Once you come here, you will learn. Or once if you go, set, or once if you start, researching on this composite material, you will come to know. Once if you get a certificate on this non-destructive testing, from the society called as American Non-Destructive Society is there, ASNT, American Society of Non-Destructive Testing, and ISNT. Level 2 certificate you have to go through. There are some industries which are giving training. Once if you go, learn that, you will be master. Diploma candidate, though he initially started with us, we have given 6,000 rupees to him. Now, after gaining 6 years of experience, 45,000 rupees he is earning per month. From 6,000, you see how much he is earning, and he is holding only diploma, and he is having very good certificates. When he recently applied for so many companies, Adani Aerospace and Dhruva, Aerospace is there, Garuda Aerospace is, there are so many industries are there. Agnikul, which is working on this, they are working on satellite in association with IIT Madras. There are so many opportunities, so many industries are there. You start search, you go get into your core area. It's an evergreen field. This composite process, it is a specialized process. Here for polymerization, again you need to go for facilities like autoclave. This molecule bonding will take place at a certain temperature. You have, if you wanted to cure that, you required equipments like autoclave. You start studying an autoclave, you will come to know. Again, while layering, while molding this composite onto the tool, again there is no process. There are two varieties. One is open molding process. What do you mean by that? You have to design a tool. Let it be a female tool, which is in a open contact. You should start layering on that. That layer by layer you are forming, that is called as layer process. After layering, what you do? You have to go for vacuum bagging. It's a special process. Whatever the air gaps, that is the total that is available between layers should be removed out. Proper compaction, consolidation has to be done. For that consolidation, we will go for vacuum bagging. After vacuum bagging, again we will cure at certain temperatures. It's a lot. It's a lot, lots and lots you can learn in this. There is a lot of scope. If you go to NDT, non-destructive testing, you will get certificate. With that certificate, you can go anywhere. You know pipelines which are totally replaced by these metal pipelines. No, totally replaced with composites. If you go to UAE, United Arab Emirates, if you go there, they are working on composites only. All composites pipes will be there. That will be checked with non-destructive testing. Under non-destructive testing, you have different tests. One is visual test. So by looking at the component, you have to find out the defects. That is called visual. And AWT, alcohol wipe testing is there. So on the component, you will be placing alcohol, and when you wipe, if any gap is there, so you can see on other side that alcohol will be penetrating into the other side. UT, ultrasonic, sound waves you will be passing. No? Through sound waves, you will find out the defects. And if you consider another test, radiography, X-ray, advanced to the radiography, now xerography has come. There are lot of equipments and opportunities. You can come. It's a specialized process. Once you start learning on all these things, right, your life would be perfect. There is no way in that. But as a youngster, you don't deviate from. right, your core elements, because you have chosen very good path. See, because nobody has guided us. So we have entered into computer science. Now we came to know that among all lakhs, crores of people, we will be the one person. Now that is not the case. We are the one who working with all the distinguished scientists. Recently, we had a meeting with the Shore director, current director, and recently we brought deputy directors to our organization. We are happy. We are sitting and working with all those people. This is what happened. And again, now I would like to tell you, this composite is already entered into the commercial area. For example, this LPG gas case is now it is with metal. There is a company called as PDH Composite Company in Bangalore. You make a note and search in the Google PDH. They are doing R&D in bringing composite cases. That LPG gas, no, that metal container should be replaced with composite. That R&D is going on. It's already proven. Soon after 5 years, you see all the metal case containers will be replaced with composites. Very good opportunities. And I would like to tell you, we are supplying nozzles. They are called as ablative components. Nozzles. What nozzle means? You might be knowing. See, I would like to explain this nozzle. See, rocket will be having motor cases filled with fuel and is propellant. See, in your crackers, no, there will be a knob. When you stick to that, what will happen? That pressure will come down and the cracker will go to up and blast. Similarly, here also nozzles are there. Nozzles will work, based on Bernoulli's theorem. The amount of pressure entering into the nozzle should exit the nozzle say, with the same amount, equal amount. Should not be any loss. There is called as a thrust. The thrust means what we do is while entering, our inlet will be having this much gap. When it goes to the middle, what we do? So that space will be reduced. To give a sudden jerk, what we do, there will be a throat. That throat is made up of carbon and throat graphite also. This has to be protected. To protect this, what we do, again composite, with composite we prepare liners, carbon composite we prepare liners there, and we will bond to the metallic hardware. When this pressure or a firing, when it enters into the nozzle, if you touch the metallic case outside, that metallic case, if you touch it, you can feel that there is no temperature for passing into that. So what I mean to tell you is we are preparing nozzles. Those nozzles are useful in launching the rocket. There are motor cases. With the help of these nozzles only, we fire the motor cases of the rocket. Those nozzles are called as ablative. What we do here, carbon and silica fabric, we impregnate with phenolic formaldehyde resin. This phenolic formaldehyde is nothing but a matrix system. Carbon and silica is not, totally they are fabrics. You understood? Initially I told one thing. Fabric we are impregnating with resin. Here also what we are doing is our carbon fabric and silica fabric we are impregnating with phenolic resin. We will form one prepreg. Prepreg, after forming prepreg, this prepreg we will take it onto the mold. We form a layup. We apply a vacuum bagging. We will consolidate or cure at a particular temperature in the autoclave or oven, and we apply the pressure also for proper compaction. After that, these liners will go for machining. I will show you the liner also. It is available here. I will show you the liners. Parts also I will show you. This is an ablative ring which will go into one nozzle that is called as HS200JM nozzle, one ablative ring, which is made up of silica. So silica fabric is impregnated with phenolic resin. What we do, we will form the layers. If you see here, these layers are formed, finally formed a product. Okay. Similarly, this is called as silica ablative ring, made up of silica fabric and formaldehyde resin. So one more thing, I will show you the another one which is made up of carbon. You see, this is a carbon liner. Are you able to see? Carbon liner? Carbon fabric totally made up of this carbon fabric, impregnated with the resin, phenolic resin, and laid on the tool. So we have pressed the male and female mold. This is called die match molding. I hope you might have learned this tool design. So what we do, we will take it and we will machine this. Right after machining, we are going to bond to the metallic hardware. So at the same time, I would like to show you the NDT machine which we use for UT test, Sona test make. If you are able to see, this is a UT machine where our people will find out defects on this liner with the help of probes. Electrical pulses will be converted into sound waves. These sound waves we can see here. In case if any right defect is there, these sound waves will not pass. UT machine. So with this, we are able to do ultrasonic testing. And I would like to show you, this is a cowling, but RCS cowling, which will be used in the rocket launch. The products, you see, it is a light in weight. I can hold with one finger. You see the strength also. This is made up of carbon prepreg, unidirectional prepreg. So, do you know the cost of this? Do you know the cost of this product? Carbon material cost, 25,000 per square meter. For this, nearly 12 square meters are required. And for processing this, we are charging 2.5 lakh. You count the product cost. And this is the disadvantage in the composites. The cost of the composite material is high. Cost of the composite material is very high. That is the only disadvantage. But a lot of R&D is going on. Slowly, they are going to cut the cost also. Slowly, it will be available to all the people. You know, the RD car piston is made up of carbon. RD car piston is made up of carbon. It's a total fiber replacement. Now slowly, our cars also, this majority of the our interiors, if you take your dashboard, if you see, what is that? Nothing but a fiber. If you see the bumper, that is a fiber. But that it's a different fiber. But slowly they are going to replace with carbon because carbon is light in weight. So I would like to show you one more presentation here. How, why carbon has, or composite material has become, advanced material in the aerospace industry. What is the reason? I will show you. I am sharing the why advancement. Why composite material is advanced in aerospace. Sir, sir, now are you able to see? See, I would like to tell you one case scenario which has been taken from the Boeing. So this is Boeing. So coming to the aerospace material is nothing but mostly, here fiber, carbon, titanium, aramides will be used. So these are called as advanced material in the aerospace. From the designer perspective, what is the right advantage by using this composite material? Coming to here, you can see in the first line reduced weight, corrosion resistant, and new design possibilities will be there. And to the industry, what we see is when such type of R&Ds are going on, there would be a new production possibilities. For example, I told you very clearly, there is one company in Bangalore, PDH Composites. They have done R&D exclusively to bring out the LPG gas container in the composite form. So for that, they have done filament winding process. This filament winding process with that, a lot of tests the container has to carry out. Once it is through, massive production it will come. And with the composite, one more advantage to the industry is once if you are able to make a mold, we can lay up to the as per our shape. So as per our shape, we can make and part joints, all these things will be reduced, and the production cost also will be reduced. And to the airlines, exclusively, who is the end user if we are going to use the advanced material? Aerospace industry. So if to the aerospace industry, see what will happen is fuel consumption will be reduced. I will show you in the next slide one scenario. Same flight, same Boeing. After using composite material, 20 percentage of the fuel consumption has been reduced, and easier inspection can be done. Maintenance cost will be reduced. More than that, longer life. See, there is one picture stating that when see 747 is nothing but the technology level that we used in the Boeing 747, 737, 757. So like this. Now, future technology levels are growing like anything as time being. And this is the history of the composite material used in the Boeing, starting from 747 to 787. Composite. Now, sir, now? Oh, okay, sir. 1 minute. Now you see, sir. History of composite material. Now, sir, now are you able to see? Okay, sir. I'll stop sharing and then I will start. Sir, now are you able to, sir, now? Sir, now it is history of composite material. Sir, there is a blue line, the blue color indicating in 747 only 1% they use. So in 757 and 767, it has been slightly increased to 3%. And 777 Boeing, 11%. 787 50%. So that means the composite usage has been increased from initial perception to the right now. And so a lot of R&D is going on to replace the remaining materials with the composite also because of light in weight. See, in 747, what they used is fiberglass they have used. Here there is a honeycomb material. Why do we use? See, there is a sandwich material, sir. To everybody, I would like to tell you in the composite, sandwich material is also available for thickness, which we use the strength. What we do is there is sandwich material we keep in the middle, and outer layers will be fabric layers. It gives thickness, and also electrical properties are there. We also manufacturing radomes, which are protective covers to the antenna. These radomes, what why we use is antenna should be protected because it is exposed to the environment. When it is exposed to the environment, we are protecting by using these radomes also. uh, when we are placing a cover onto the antenna should not disturb from its functionality. Hello? Yeah. Yes, sir. So now carbon composite concept has come in the year 1970s. Initially, they started the NASA people. They started with one program, ACE program. So slowly, wherever this trail edge beam, upper skin panels, they started, manufacturing or replacing the previous fibers, glass fiber with the carbon. And these are all the indications what we have given. And production implementation has come in the 1980s for Boeing 757 and 767. Here you can see the parts, engine cowl. Now engine cowlings are totally replaced with carbon. You see one of the RCS cowling I have shown you, one structure. I have shown one structure and explained the cost also. So in 1990s, wherever this green color is there, it's nothing but a carbide. Whereas hybrid combination, glass and carbon hybrid combinations are also there. So now if you see in 787, total this blue color totally replaced with the carbon. You can able to see here. See where these materials matter, where we are using. So everywhere we are using in the aerospace. What is the reason I will tell you? If you take aircraft or aeroplane, airframes in the sense wings, so related to this flying, landing gears, all these things are made up of advanced materials only. And interiors, now the seats are also totally seats, overhead bins, linings, bulkheads, cargo restraints, floors, everything are totally replaced with the composite because of high in strength and less in weight. And in the propulsion area, I have been telling fairings, cowlings, exhaust, acoustic. Why do we use carbon material in the propulsion area means? What is the reason means? Because propulsion is nothing but an oxidant, fuel that it takes. So when we burn that fuel, automatically at 1000 degrees or 1500 degrees Celsius temperature will be there. There should be a material to withstand. If you use the metal, what will happen? Automatically at a certain hundred in the hundreds degrees Celsius temperature, melting will occur. But at 1000 degrees Celsius, if you use the material, carbon material, so what will happen is, or advanced any composite material, even if you use a Kevlar, this melting point will be at higher temperatures. So that's why carbon material or a composite material is totally used wherever the propulsion is there. See, I would like to tell you 90% of the material in the rocket launch totally goes, the composite material only will enter into the launch. The reason behind it is propulsion. 400-ton oxidation will be happen. So here are the advantages they are telling, as I have been telling: lighter weight, better damage, uh, and manufacturability will be improved. It will withstand for higher temperatures. Because of all these reasons, this material is used. And I would like to show one more slide also. What exactly at high tech what we are doing. So what facility we have, that also I would like to show you. Sir, sir, now are you able to see? Sir, recently, see, these are the PBR tubes, which each tube will take 12-ton load. Shar director, Rajarajan sir, recently visited our factory. This is a clean room where lab process goes. And and even I would like to show our high tech facility, what we have and what we have supplied. Sir, here you can able to see high tech projects is we are aerospace industry having a AS 9100 standard like our NBA NAC. We also have a standard. Hello, hello. Yes, sir. See, our organization is especially, especially it is for composites, advanced composite material. And our manufacturing autoclave, we have CNC filament. All these things I will show you. So we use carbon fabric, glass fabric, silica phenolic, and honeycomb, epoxy. What will I told the same thing. Our facility. See, this is our quality policy. Every organization will be having to meeting the customer's point. And here are the structural components, which you can see what we have supplied. ITSC tubes, see for aerospace industry. If you see ablatives, nozzles, what we are supplying to defense, what we are doing. Our manufacturing equipments, impregnation plant, we have element winding, we have autoclave, we have hydraulic press. See, you can able to see the plant where we are going to impregnate the carbon and silica fabric with phenolic resin. And this is the CNC filament winding, as I have been telling that containers, LPG gas containers can be made up of by using, carbon by filamenting. And this is an autoclave where it will be operated at 4 bar pressure and temperature, 200 degrees. This is another autoclave of having bigger dia, 3.5-meter diameter products can be accommodated here for curing. And this is an hot press where female and die match mold is there. So these die match mold in between product will be there. That will be compressed by giving the load. and electrical oven. There are few components which can be cured or polymerized at certain temperature without giving pressure. For that, a oven is used. And vacuum bagging. This is how vacuum bagging is placed. And there are some compressors and cold storage. See, actually, these pre-preg material should be stored at minus 18, and there are few pre-pregs which we have to store at plus 4. For that, cold storage is required. We have cold storage to store the pre-preg because all these material are shelf life materials. And this is the clean room where we have to process. Even dust particle should not enter while lab. FOD, foreign object debris, it should be zero. Foreign objects we are not supposed to allow. And CNC lathe machine for machining the liners, cranes, and it is a UTM mechanical testing. I hope you know ASTM standards. Based on those standards, we are able to test tension, compression, flexural, shear test. All these tests we are able to do. It's an UK based machine. And this machine I have shown where which we use for UT for non-destructive testing. And laser tracker we have. It's a portable for measurement, dimensional inspection. And for we have few facilities to test the viscosity and muffle furnace to test the samples, small hot air oven, and there is a big Brookfield viscometer, structural test facility. It is a pneumatic based setup for testing the loads, tension, torsion, and we supply the products to Honeywell, DRDO, Hall, Bharat Electronics, ISRO, Allbit, Datasol, Valiga, Data Patterns. This is what we are having actually for processing all the composites, whatever we explained. So my sincere advice to all the people, those who are sitting in the conference hall, especially to the students, lot of scope is there. Only thing is you should go and research on the composite material and you should know the opportunities. See, from this I can tell you one point is if you wanted to learn non-destructive testing, you can learn it. From this, you are able to find the defects. And if you wanted to test the material properties, if you wanted to know, then you can start learning how to operate the UTM. All basics things you can start. That mechanical testing, universal testing machine means what? How mechanical testings will be followed, and this ASTM standards, how it will be. So, if you wanted to test, what are all the methods that are there for flexural modulus? You find out the ASTM methods. So you will come, you can explore in that aspect. If you wanted to get into the production line, then it's a great opportunity. Already we discussed with Vikram sir also. You can have one visit to our industry to see the process and how it is going on, and you can get into the production line and quality aspects. If you wanted to learn, you can also be a quality aspect. As I told, we have aerospace industry. Quality management system in the aerospace industry is very, very important. The reason behind it is 100% security should be there, and there should not be any single defect also. So that much care we are taking here. So that will be monitored by one online QC. Real time quality control will be there. So it's like one person will be manufacturing parallelly, another person will be checking. So these are all the aspects you have, opportunities you have to come into the manufacturing industry, especially in the composites. So this is how about the opportunities. Uh, Thank you, sir. Thank you. everyone. If you have any queries, you can ask. And I would like to introduce one more person, Mr. Prasad. He is available with us, who has come along with me. And now he is working for Bharat Electronics. He is also one of our alumni from the same mechanical background.
Hi, friends.
He is also one of your seniors.
Hi, sir. Yeah, fine, sir. Going good, sir. Yes, sir. First thing is composites. The composites having more scope in nowadays, like defense, and after that aerospace, even automobile also nowadays they are using composites. So if you are interest means in our college we are doing in metal matrices like aluminum composites, everything we are doing, right. So here we are going to do fiber composites like carbon epoxies, they are all fibers. Nowadays we are doing abrasives also like nozzles. You hear, right, all every rocket requires some nozzles. So 1 second, we'll get a nozzle and
even we will show you one nozzle also, 0.5 meter nozzle. Metallic hardware will be given, as an free issue material by VSSC, Vikram Sarabhai Space Center. And liners will be bonded to that metallic hardware. Inside, as I have been telling, that there will be a temperature. If you see there, that aerodness will be, very less. And if you touch outside the metallic hardware, if you see, you will feel that nothing is there. But inside 1000 degree and 500 degrees temperature will be passing. And recently we supplied, see now we are working for Gaganyaan machine. We, out of five varieties of nozzles, we have developed three varieties, and fourth one is under development, and fifth one is, in-house made. You can see this is one nozzle. So it's a high pitch motor nozzle. High pitch motor nozzle, metallic hardware. You can see this is a metallic hardware. So divergent liner is bonded to this. It's a carbon fabric, impregnated with phenolic resin. You can see here. This is bonded with araldite. So like that, see one more liner is also bonded. Two liners. Like this, we will be bonding all the liners and final machining. After final machining, we will be supplying to VSSC. Is one nozzle which will get into the Gaganyaan mission. Thank you.
The first what we are seeing remaining 63 compared to first one is